Okay, now one law, I mean gas law you have to study, which is called Dalton's law of partial pressure. So what is this Dalton's law? This is the law for the gas. According to Dalton's law, suppose this is a container, and the container must be closed if you keep the gases inside the container. Suppose this container contains three gases A, B and C. There are three gases present here. But these gases must be non-reacting gases. I mean, they should not react chemically. Otherwise, Dalton's law will be not applicable. So, if two or more gases are enclosed in a vessel which are non-reacting gases, then the pressure exerted by the individual gases, I mean, what pressure is given by A, what pressure is given by B, what pressure is given by C, that pressures are called partial pressure. I mean, partial pressure means nothing, the individual pressure of the gases. According to Dalton's law, if the temperature is constant, temperature must be constant, then you can apply the Dalton's law. According to Dalton's law, the total pressure of the gas mixture, which is represented by capital P, this is equal the summation of the partial pressures, I mean PA plus PB plus PC. This is according to Dalton's law. I mean, when two or more non-reacting gases are enclosed in a vessel, then the total pressure of the gas mixture is equal to the summation of the partial pressures of the individual gases at constant temperature. This is called Dalton's law. Always remember, the gases must be non-reacting gases, and the individual pressures, what pressure given by A, what pressure given by B, what pressure given by C, that pressures are called partial pressures, and partial pressure represented by small p, and the total pressure of the mixture, total pressure always represented by capital P symbol. So this is about the Dalton's law. So if you want to write the statement, if two or more non-reacting gases are enclosed in a vessel, the total pressure of the gas mixture is equal to the summation of the partial pressures of the individual gases at constant temperature. Don't forget to write at constant temperature, otherwise the law is not applicable. So if the gases are A, B, C inside the container, then the total pressure P, according to Dalton's law, P is equal, you can write PA plus PB plus PC. If another gas is present, D, suppose, then P is equal PA plus PB plus PC plus PD, like that. So total pressure of the gas is equal to the summation of the partial pressures, I mean the individual pressures of different gases. This is the Dalton's law. Now let A and B gases are enclosed in a vessel of volume V, is the volume of the vessel, and if Na, Nb be their number of moles, then at constant temperature, then at constant temperature, you can write, see, you know PV is equal nRT, or P is equal, you can write nRT divided by V. This is for ideal gas equation. If the gases are ideal, and if you want to write the equation for gas A, then you have to write PAV is equal nART. Because volume is constant, R is constant, temperature is constant, that's why instead of P you have to write PA, I mean pressure of A, and instead of N you have to write Na, I mean number of moles of A. That means you can write PA is equal nART divided by V. Similarly, for B gas, this should be small p because these are individual pressure, I mean partial pressure. PBV is equal, you can write NBRT, or you can write PB is equal NBRT divided by V. Have you got it? Since the gases are ideal gas, so you can apply the ideal gas equation. Now, as you know, from Dalton's law, what you have got? From Dalton's law, you have got P is equal PA plus PB. I mean, the total pressure is equal to the summation of the partial pressures. So, PA means you have got NART by V. PB means you have got NBRT by V. So if you take RT by V common, then you can write Na plus Nb. So this is about the total pressure. Now, if you want to do PA by capital P, I mean partial pressure of A divided by total pressure, then what you will get? PA means already you have got NART by V, already PA is equal NART by V you have got, and the total pressure P is equal, you have got RT by V Na plus Nb. This is total pressure is equal RT by V Na plus Nb. Now this RT by V will be cancelled. Ultimately you can write Na divided by Na plus Nb. What is Na? Number of moles of A divided by number of moles of A plus number of moles of B. You know, number of moles of a substance divided by total number of moles, that is called the mole fraction. Ultimately you can write this is equal Ka, mane mole fraction of A. So that means you can write PA divided by P is equal, you have got Ka. That means you can write PA is equal Ka into capital P, total pressure. I mean, this is one of the equation by which you can determine the partial pressure of a gas. Partial pressure of a gas is equal to the mole fraction of the gas multiplied by total pressure. Similarly, if you want to determine PB, partial pressure of B, then you will get Chi B into P. I mean, partial pressure of B is equal mole fraction of B multiplied by total pressure. So this is very important for in exam. Normally the question asks, prove that partial pressure of any gas is equal mole fraction of the gas multiplied by total pressure. And in numerical also you can use this equation if you want to determine the individual pressures, what are the pressure of A, what are the pressure of B. I mean, if you want to find out individual pressure of the gases, then you can apply this one. Just you find out mole fraction and you multiply it by the total pressure, then you will get the partial pressure of the gases. And if the total pressure is constant, suppose total pressure is constant, if this one is constant, then you can write PA is directly proportional to Ka. I mean, the partial pressure of a gas is equal to, directly proportional to the mole fraction of the gas at constant total pressure. I mean, if the total pressure is constant, then the partial pressure of the gas is directly proportional to the mole fraction of the gas. In exam, the question may be asked like this: prove that at constant total pressure, partial pressure of a gas is directly proportional to the mole fraction of the gas. So from this equation you can prove it. But if you want to derive it, if the 2 mark streamer is given in your question, then you have to derive all these things. I mean, from that point you have to write let A and B gases are enclosed in a vessel. From that point you have to write. So these equations are very important for your numerical also. If you want to determine partial pressure of a gas, then you can apply these two formula. Partial pressure of any gas is equal to the mole fraction of the gas multiplied by the total pressure. And what is mole fraction? Mole fraction means nothing. It is the number of moles of the substance divided by the total number of moles of the gases present in the mixture. And if the total pressure is constant, then partial pressure of a gas is directly proportional to the mole fraction of the gas. So this is about the Dalton's law of partial pressure.